In this module, we shall start with the introduction to the NED language that forms the basis of simulation in OMNeT++ environment. So far, we have discussed the importance of C++ based libraries for simple and compound modules. However, we also discussed that the reusability of these simple and compound modules is actually the strength of OMNeT++. It is the NED language that realizes so. We are also going to look at the graphical editor-based immense support that is available to students as well as researchers which are not very savvy in programming. They can exploit the presence of GUI-based support to facilitate their simulation experience. What is NED language? As the name suggests, it is the network description language. It creates the topologies in OMNeT++ environment. The topology, of course, comprises the network that consists of simple and compound modules. Using the graphical support, the users can drag and drop simple and compound modules in the graphical window, and correspondingly NED source code is generated. On the contrary, if the users are good in programming, they can switch to the source code editing window and they can modify the placement, the behavior, the properties of the simple and compound modules, and correspondingly the NED visualization on the graphical window is going to change. NED comprises certain essentials, which include the definition of the network, the definition of the compound modules, and the declarations of the simple modules. It is important to notice here that the simple modules are not defined here. They come as C++ basic files. So these are not defined, rather declared. Anything that the users want to modify in the simple modules has to be done in an object-oriented way. The network definition part includes the definition of simple and compound modules, which actually are the building blocks of the overall topology. Once a network is created with simple and compound modules, it becomes like a self-contained simulation platform. Just to give an example, if the users are interested in implementing a one-hop wireless communication scenario, they would need at least 1 to 2 computers and a wireless access point. So these devices are declared in NED language. Another example could be establishing a connection between a computer and a server using a wired environment. For that, the components would be required as simple module and compound modules as computers, the cable, and the server. The simple module declaration is nothing but giving or passing parameters as data. As we discussed, the simple module comprises gates, which serve as input and output places for the simple module, and the internal behavior of simple module can be tailored by giving it the data through the parameters which it exposes. The compound module definition includes declaration of external interfaces for the compound module as an extra or exterior environment affair. Then on the inside, it needs submodules and their interrelationships. On the external side, it needs gates and connections, the parameters which are assigned to the external side of the compound module, and on the inside, the gates and the links between its submodules. Although NED language deserves extensive teaching sessions, but for the sake of brevity, we shall start, at least for now, with an introduction to the creation of network, that is a topology, using the graphical support. Let's create a simple topology called my network. So, using the graphical support, we shall create a network, my network. This is actually the workplace where submodules, simple modules, and compound modules can be placed. So we see here, we have simply dragged and dropped a simple module. We call it my module. We also place a compound module. In this case, an example of the compound module is a standard host. If you look at the 7-layered ISO-OSI architecture or the TCP/IP architecture, it comprises different functional layers. A standard host implements most of the basic level functionality of these layers. So, a standard host on the outside looks like a simple module, but on the inside, it comprises multiple simple modules which realize different sets of functionalities. So the connection and the gates between each of these submodules become the issue of interest.